Okay, here we have number 42. I'm going to have to move my vertical axis over to the left a little bit here. Now, we've got y equals the opposite of log of x plus 1. A couple of things that are happening here is you've got a base 10, so that's a base 10 right here. And then the other thing is that we've got some transformations that are happening. So this transformation right here, this opposite on the outside, is a reflect over the x-axis. And then this plus 1 on the inside is left 1 unit. And what's being reflected, what's going left, is the parent function. So your parent function is y equals the log of x. Now, log base 10 of x. So I'm going to plot that parent function first. Log base 10 of x. Log base 10 of 1 is 0. So you put a 1 in, you get a 0 out. Log of 10 is going to be 1. Log base 10 of 10 is equal to 1. You put a 10 in, you get a 1 out. And then the next one that would work would be 100. That's how you're going to get a 2. Log base 10 of 100 is 2. And that is going to be way off the grid. So we're really only going to have 2 lattice points here that we can work with. 1, 0, and then 10, comma 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, comma 1. Okay. But we know what this function looks like because it's a logarithm. So it's going to have a vertical asymptote. And it just, this one's going to be hard to draw because it's going to curve around and then it's going to slowly come up there and pass through. And this, golly, I just can't get this right by doing it in one swoop. So I'm going to have to do that. There we go. That's really what it's looking like. It's just slowly going to increase out here. Because remember, it's not going to get up to 2 until you're all the way at 100 as an input. So when you put 100 in, that's when you're going to get up to 2. So this is just slowly, slowly, slowly increasing. But that's your parent function. And what's nice about this is that you only have 2 lattice points that you have to work with to reflect over the x-axis and go left 1 unit. So that's what we're going to do. We're going to take this first lattice point, 1, 0, and I'm going to reflect over the x-axis. So it's on the x-axis, it's not going to go anywhere, and then it's going to go left 1. And then we're going to take this point, we're going to reflect it over the x-axis, and then we're going to go left 1. And if you did number 41, you know that going left 1 is going to move that asymptote, that vertical asymptote, to the left 1. And reflecting over the x-axis means this graph is going to come in like this, and it's going to curve down. And that's our graph. Y equals the opposite of log base 10 of x plus 1. The domain you can find by taking the argument, setting it greater than 0 and solving. X is greater than -1, therefore the domain goes from -1 to infinity. And then the range on logarithms is always all real numbers, so it's -infinity to +infinity. And then the asymptote is found by setting the argument equal to 0 and solving x equals -1. And that's right here, x equals -1. There you go. Now, when you're graphing this, you don't have to graph the parent function. So really the answer to the problem for both 42, 41, for all of these problems in this, when you're graphing logarithms, if you use the parent function to transform to the new function, you really should delete out that old function. This way on your graph, all you're showing is the graph that they're asking you to draw.